Marty Koistra here with HDC, and really want to thank Becky, Joe, Scott. So many people have been working really hard to get us to this point today. Let's go ahead and run through some introductory slides here and then get deep into the content Joe's talking about. So what we really want to do is talk a little bit about why we're doing these guidelines and workshops, and then really want to get deeper into this whole concept and practice of early integrative design and make sure that we're capturing your questions, suggestions, and application opportunities with that as well. So we've got one more of these workshops left, and that's coming up on December 3. I should know, but I don't think that's next week. I believe we've got a 2-week period here where we will do balanced ventilation and heat recovery. And another very technical topic, but timely and imperative as we move into the new code. So I think Lauren's going to do her magic and pop up a poll opportunity here if Zoom will allow. Let's see if that happens.
Well, Marty, Zoom is not allowing at the moment, so we may need to defer this towards the end.
Yep. And that does happen from time to time. So thank you for your tenacity, Lauren, in trying to manipulate the technology. So the Exemplary Building Task Force is an interdisciplinary team of mostly volunteers coordinated by HDC, has a broad depth of experience and so on, working for quite some time now on really trying to drive this notion of the Exemplary Buildings program. But going on to the next slide, we don't think that these practices are just relevant for our demonstration projects, but we hope that we can inculcate the entire culture with this market transformation, getting us there through all of the learning that's taking place in this program. So we have a multi-pronged goal. I think you all know this by now. We're talking about healthy homes because we care about the residents, the people who live in them. And there's a new awakening around health with the pandemics, with the fires, and with everything else. And that also leads us to this issue of climate change and preserving our environment while creating durabilities to reduce those long-term operating costs. And we're really wrestling with this tension that you all know, which keeps slapping us in the face, that first costs are king and queen, and life cycle costs have to be subordinated to that issue. We think that we can be smart enough here with our innovative culture, our innovative thinking, and our brilliant leaders to not have to minimize the units we produce and hit these targets. So just quickly, we started this effort by drafting some specifications and recommendations on the left. We've been doing these charrettes, which are real deep dives into the issues with a lot of thought leaders. We're coming out with these workshops, which are really appetizers that will lead into access to guidelines documents. You know, the wall assembly guidelines are on the website now. And then next year, we launch into deeper dive trainings and workshops. And all of this will allow us to iterate all the way through the process to continue to learn and improve. So we've had all of these topics on our radar. Early integrative design is today, key one, exterior wall assembly, domestic water distribution, heating and management, balanced ventilation, heat recovery, solar integration, and soon to be healthy buildings and operations. And you can see here what our schedule is on that work. Again, don't forget the Exemplary Building website address, and Lauren will probably put it in the chat for you if you don't know how to find it. Okay, I'm about to hand it off to the experts to get you to the stuff you really came for today. And that's to focus on this concept and practice of early integrative design. And I couldn't be more proud of the team that's been working on this. And they have really been working hard. Let me just say, it's obvious they have passion for this and they care. So I'm going to turn it over to Joe, Becky, Scott, and whoever else they're gathering up to present the topic. Thank you, everyone, for being here with us.
Well, thank you, Marty, for a great intro and for your leadership in this whole process. And I also want to recognize not only the entire Exemplary Buildings Task Force, but the specific people who have been helping since we started the EID charrette in July, and those who have helped put the guidelines together, which are in progress, and then the workshop here today. So the question is, what is the topics that we're going to cover is what is early integrative design, the context that we're working in, a listing of those exemplary measures and how they specifically impact the results, going back to the goals of the state. Then Becky will take over with the process guide for EID that we will hope to publish here before the end of the year. Some examples in practice from Scott, specifically with one of the demonstration projects by SHA, the SAWARA project at Yesler Terrace, and a mini wrap up in the end about CEDC and cost-efficient design. So what do we mean when we talk about early integrative design, and how does it work to make a priority of these things up front, of goals, objectives, and the direction of the project? We know that knowledge of the opportunities, costs, and constraints that are put before an aligned design team and construction team that engages in early design charrettes with well-defined budget and project goals can produce the highest performing building with the means available. And that's sort of the overall picture. So reminding ourselves of something that we all know, but sometimes don't have the ability to fully engage in, is the fact that what happens early in the process is the most impactful to the entire success of a design and construction and operation effort. So on the first line, the blue line that says number 1, we know that the ability to impact cost and function capabilities diminishes from day 1 going forward in through construction and operations. And the ability to, the cost of making those changes in the red line, number 2, increases over time because of the disruption to everything that's happened before. So when you look at lines 3 and 4, we're talking about the time and effort for the team that's currently focused toward the middle of construction documents really needs to be pulled back toward the beginning, where we have time and effort put in the beginning to make the decisions that will impact everything else following. We all know this. It's challenging to get the resources and time to do it up front, but that's really what we're trying to emphasize in this exercise today. Now in British Columbia, they've created a roadmap, and they talk about how continuous learning and improvement is imperative for integrated design. That's not a linear process. It includes feedback mechanisms during the process, and that this enables, this iterative process enables decisions that reflect the team's collective knowledge with regular feedback loops that can keep the team both engaged and produce successes step by step. That's like one snapshot of way of looking at it. So just to remind everybody of what we've been doing to date in the Exemplary Buildings program is to look at the context we have. Besides the fact that we have a dramatic need for more affordable housing, we also are in the context of dealing with a changing energy code and its move toward 2030, when we are being asked to reduce energy use in buildings by 70% from 2006. So in this graph, you can see how that progress is going, where our 2018 code will be relative to the target of getting to 2030. And then on the commercial side, the dark line, we are not quite in line with the reductions needed. So we need to do better. And here's another way of looking at that same information, that in 2018, our new buildings are someplace between 30 and 35 EUI, which is energy use per square foot. And we need to be down closer to 15 to meet the 2030 goal of the state. So the exemplary measures that we've been focusing on include some things I'd like to just point out as a reminder. Number one, balanced ventilation with heat recovery, something we started talking about 2 years ago as one of those measures, and now is very likely to be part of this 2018 code coming up. And so it's now code. So it's an example of something taking place in that time frame getting to 2030. And some of the things that come with that, besides energy reduction, energy consumption being reduced, the biggest values are really having good air quality by removing pollutants and CO2 and reducing the risk of building envelope failure. So it's a health and building durability factor, and to a little less extent, the energy consumption. Looking back on that chart that shows the process toward 2030, the biggest change you can see there is in orange, which is the domestic hot water, which takes up a very large chunk, the largest single chunk of our energy use today, and can be reduced dramatically with the measures that we've been discussing in our workshops on domestic hot water. And one of the main reasons is the way water is distributed in a building. Yes, we can switch from gas to heat pump hot water, but the biggest savings really are available through how we distribute the water through the building, both in the time to tap within the unit, which saves water and energy, and the pipe sizes and how the insulation is handled on those pipes, which can make almost 100% difference in the energy used to supply hot water. Another major focus has been wall assemblies, and where we can optimize wall assemblies, with this particular one being the recommended solution, which is a 2x8 advanced framing wall system that we'll see discussed a little bit later by Scott in their work on the SHA-SAWARA project. We've also had some great work done on integrating solar PV, and that's one of our promising practices that's already had its charrette workshop to date. But in all of this process where we're trying to improve what we're doing, it's key that we have leaders who kind of champion the improvements and also respond to the forces on their teams and in the process that might hold things back. And so this graphic that Marty has shared with us tells us to keep in mind that we may see a portion of this evident in a team or in the process, but there's a lot of things going on below the surface that we really need to give attention to in forming our teams, motivating our teams. And that's where I think Becky will help us start looking at what the process guide might do to help us do that. So with that, Becky, I'll turn it over to you.
Great. Thank you, Joe. Hi, everyone. I'm Becky from Walsh Construction. And I'm here to talk about where we're at in process recommendations. So, this is the less sexy side, I think, of building a building and designing a building, but really important to our work. And so, as Marty mentioned, we're in the process of developing what we're calling a integrative design process guide. It will be, I think a lot of folks out there might like a very detailed checklist of everything to do during the pre-construction phase to really develop a good design. And I think each project and each team is so different that we're landing on more of what we're calling a process guide. And so it's really a list of sort of key considerations and questions that your design and construction and ownership team can ask during the very critical early design stages. And I grabbed this graphic because this was what it feels like sometimes. It feels like you're under a lot of pressure. It can be quite stressful, and you're trying to really corral a lot of different pieces while, building the airplane while you're flying. And my analogy was sometimes it's you have a lot of time and resources for the effort, and it's more like flying from 50,000 square feet. And in other cases, it's way more condensed and it feels like you're falling from 500 feet. So some of this process work can really help you manage both of those situations. as Joe mentioned, one of the differences, I think, to a typical design process compared to an integrative design process is the notion of iteration, and also really pulling in constructability feedback. And so we put together this graphic, which we felt like really represented the process that a project might go through, where obviously each ownership team is doing their initial planning and very initial feasibility work, but then hopefully selecting what is a high performance, cost-effective path. And once you select that path, there's this iterative process of checking against code requirements, constructability, cost, and then performance targets, which can get a little technical. And so in some cases, you might need some analysis to support your efforts. And the goal being, the green arrow at the right side, is that projects go into their funding efforts having done at least some of this, so that they're coming in with the most cost-effective yet highest performing project into the funding process. And so as we've kind of reiterated, there's some real keys to this, which is very intentional goal setting and team building. So trying to get folks out of their silos a bit, maybe earlier than you might think, as we've noted, some of these new measures that are driven by code or high performance are somewhat technical. And so it really is setting a framework of collaboration and soliciting that expertise. And I would say one of the missing pieces to some planning efforts these days is really effective integrative scheduling. So this is, everyone bringing their process expectations to the table, as well as some key financing deadlines, to really make sure everyone has awareness of what goes into getting to schematic design, for example. What goes into a design build process. I think owners can have a very different interpretation of what design build means compared to a general contractor. And so really kind of flushing that out. And then, as we've said, a very early focus on cost efficiency in order to make sure that your project is queuing up for funding success. So advance. So this may be a familiar graphic to a lot of people, hopefully, but some of the line items might be a little different. So, every project goes through a scheduling exercise. Sometimes it's created by the architect, sometimes it's created by the contractor, sometimes by the owner. Whoever creates it, I think the recommendation is that it maybe becomes, you want to think about adding some new elements to it. So consideration of exemplary building might go into some of these early stages. Layering in financing deadlines might come into it. And then, some of the key sort of review and option vetting processes that we might go through, you could also layer in here. But I think one of the takeaways from this graphic is to show that it can really take up to 1 year to 18 months to kind of effectively get through an exemplary building design vetting effort. So backing up from, say, you want to bring, a good schematic design and pricing effort into your financing application, really backing up as to when you need to be selecting your design team and starting to bring in some of those sub-consultants that might really help inform your performance path. You can advance. So looking at the early phases, and this is just a preview of some of the questions and considerations we're going to put in our process guide, but there's a lot put on that early ownership effort. And as we'll hear Scott say later, having an early clear definition of performance goals can be incredibly useful. So starting with high performance, maybe setting a target for what is high performance for your organization. It might be an EUI target, as Joe mentioned, or it might be related to another opportunity or another criteria that you set. But going through that goal setting process can be hugely valuable. And then obviously some of the other external factors like financing and energy code and building code, as we've talked about. And so once again, in the process guide, we'll go through what, besides the questions and considerations, what might you look to see happen at some of these stages. So coming out of an early stage with that consensus and with a really intentional team selection process. So not only are you intentional about how you select your team, but you're understanding how much it costs. So besides, your basic architect costs, what other consultants might you have in play and how much do they cost and what sort of pre-development budget are you needing to manage and find resources for? And we also put in here, as you're going through roles and responsibilities, are you identifying a champion or champions of that assessment of high performance? That can be really critical and really moving that effort along. Go ahead, Joe. And as we've mentioned, that these are very technical design issues that are coming up. And so besides what a lot of projects, these, for the past however long ESDS has been around, have done sort of a one charrette meeting to satisfy the ESDS charrette requirement. And I think what we've seen is that perhaps, the intent of the ESDS charrette could be accomplished through a series of meetings. And certainly the intent of vetting high performance options can be accomplished through a series of meetings. So things like a specific plumbing meeting or a framing meeting, Walsh has really seen a lot of benefit to pulling some of those subs into maybe an early SD design effort to really get their perspective on, what do they see as strategies to be cost effective? What do they see as strategies to hit performance goals? So that's been a really valuable effort. And then I think also being mindful of cost. Obviously, we know we're under a lot of pressure from funders around cost and schedule. And so is there a cost target that the team wants to try to work towards as they're going through design efforts? And then, as we mentioned, the need to iterate and just constantly revisit things like that integrated schedule and your financing criteria, or if you have criteria of an incentive program like Seattle City Light. And I think, one of the last things to point out is that what we've seen a handful of projects be successful in pursuing performance, where maybe they were a little hesitant at the beginning, but they leaned on the team to put forth some options, and then in deciding which option to pursue, set criteria for, how to make that decision. And so besides that upfront cost, just assessing the impact on the performance of the building and how it fits in with other systems in the building. So really working on that systems thinking, and Scott will really talk about that here in a minute. And then I think, the last thing that is really important for a lot of operators is some of those qualitative impacts on operations and making sure that ownership and maintenance staff feel comfortable with the systems that are being proposed. And so, some of the key strategies that we've seen and tools that we've seen that can be helpful that maybe owners typically do a little later, but maybe want to consider doing a little earlier, is using some tools like energy models and life cycle cost analysis. It doesn't need to be a full-blown life cycle cost analysis, but perhaps exploring for some of these new systems, some of that upfront cost versus long-term benefit. And then really honing in on some strategies. A lot of these new technologies with heat pump hot water heaters or venting systems really have impact on design. And so it's just, it can be very critical to hone in on where these things lay out in the building fairly early so that you're avoiding costly design changes down the road. And so locking in those design decisions early is critical. And then, the process guide, and today we'll talk just a tiny bit about, of your past schematic design. So your project's funded and you're moving towards construction. Don't lose your commitment to iterative design and iterative exercises. And so really checking in with partners, checking in with your consulting team, and really revisiting your schedule and what it will take to get everyone's eyes on that final set of drawings and specs, and feel like everyone's in agreement with what is going into the construction period. And then obviously don't let up the pedal on performance to move those conversations forward about how performance can be ensured during operations. So that's kind of a whole nother topic that it sounds like we're going to cover in the coming years, but making sure to put those planning activities in your calendar around operations. And I put this in here because by doing this, going through this process, but hopefully memorializing some of these key decisions, building them into perhaps some ownership design guidelines, which I know a handful of folks out there have, but I think our argument here is that they can certainly be enhanced, that hopefully you can take some standardized design approaches into your next process and absolutely breeze through your next project's process. So I'm going to kick it over to Scott Crosby from Ankrom Moisan Architects. He has been a key player in the early integrative design efforts at SHA-SAWARA project and the Yesler Terrace area. So he's going to tell us a bit about how their team has worked to implement these practices.
Thank you, Becky, and thank you all. My name is Scott Crosby. I'm a project manager with Ankrom Moisan Architects, and you are looking at an image of the Seattle Housing Authority's SAWARA project in Yesler Terrace. It's block 7.3. Next slide, please. So looking at SAWARA and the early integrated design process, kind of some of the primary ingredients or components that were present here that were extremely valuable. Number one was a champion. Tom Eames from Seattle Housing Authority, a great deal of experience of knowledge of these building types, and was enrolled completely in the value of an efficient and durable building. He knows the operations as well and knows what costs money. So his championship really rippled into Seattle Housing Authority. So they had a firm-wide commitment, allocating resources, commitment to a high-performance building, really taking the time to do some life cycle costing, again, for that durability and operation costs. From the beginning, the measurable results, we set out an EUI of 20, and we did have a construction budget from the beginning, so those were critically important. The consultant team, there's many different words could have been placed here, but dedicated, I think we in general are a very dedicated group to this. It's a very good team. And the last one is interesting. Team chemistry is so important, and it's been a very rewarding project. The level of communication in working together, rolling up the sleeves and setting a bar for, no, I can't just do this item myself. I have to cross-reference with the rest of the team. So feel very special about that. Next slide, please. Okay, so a little bit about the team. General contractors, Marpac Construction, but note here that mechanical plumbing is Ecotope, energy code compliance is O'Brien 360, and our building envelope is RDH, all of which have been very active in the exemplary building program. So another tribute to the efforts of this group and Marty and to Tom at Seattle Housing Authority for choosing to have these consultants on the team. A little bit about the building. We're 114 units. We are type 5 over type 1. We're approximately 126,000 square feet. I provide the unit breakdown only to show you the main takeaways. The 2 bedrooms are about 20% or 23%, and the 3 bedrooms are about 20%, which is a little higher than some of us may have been used to seeing. Next slide, please. So on this slide, it gives you an idea on the right, the basic shape. This was generated from several factors. Number one being the owner really wanted a secure but light-filled courtyard, eyes on the kids for playing. The orange represents 3 bedrooms, the green represents 2 bedrooms, and the white are 1 bedrooms. And the 2 and 3 bedrooms have been placed on the corners to take advantage of light on 2 sides and the efficiencies related to that. The left side is just an enlargement of the 1 bedrooms, and that will come into play a little further down. Next slide, please. Okay, so the wall assemblies, an item that the task force has spent a lot of time on, I was very concerned about from the beginning and thrilled with the team. So we did have preliminary discussions with the consultants to prepare for a design charrette. And it was very important, the timing. We had some of our basics down, but we knew it was time. And the charrette attendees included Marpac, the general contractor, Ecotope, mechanical and plumbing, RDH envelope, O'Brien 360, and of course, structural and AMA. So the design charrette was, in COVID time, it was a Zoom meeting, almost 2 hours long, but several elements of the discussion. I'd been a big believer in exterior insulation. So many times, all of us, I think, have walked through our buildings while they are under construction, and we look at the exterior wall and the exposed studs, and there's stud packs and hold downs, and it's like, how do we get enough insulation in here? And that's why at first I was thinking the exterior insulation would prevail. However, as the team discussed and went through this, there were several elements that were really helping us lean toward the 2x8 at 24 inches on center. One is the unit layout. The spans for the bedrooms and the living rooms are not that great. They're like 10 to 12 feet. We're predominantly running the joist parallel to the long length of the building. And what we're doing is keeping less tributary area off that exterior wall. Another item that we did, we put the shear walls inboard, so we don't have any hold downs in the exterior stud wall cavity. The real savior, we were going back and forth between David and looking at our overall, David Reddy, our overall R value and fastening systems through the exterior insulation, and there were a few items that were tipping points. And number one, kind of being a part of the group and really understanding Walsh's CEDC, we started with a 2-foot grid. So the building was already on a 2-foot grid. And that really is critical for the efficiency of the 24 inches on center. The other item that we had was MARPAC wanting to panelize the exterior walls, and as part of that, do shop drawings. So when we get to, and we have more to do in the corner details, although we started with one stud in the corners to really fill the insulation. That and the sequencing of the exterior insulation with MARPAC there, that was a substantial cost. There were some interesting discussion points and ramifications. The windows are all on 2-foot modules, and we had to counterbalance with some things in the zoning code as far as blank wall areas. We could not do a window 5'6", so everything had to be on an even module. Our discipline in keeping the studs at 24 inches on center is what the team agreed to make this cost efficient, and this is what the team selected. It was a great, great process. Next slide, please. Okay, so balanced ventilation and heat recovery on the right, and the team chose to do, really Tom started with this, individual unit, the heat recovery in each unit. On the right is the model we selected. Note the intake locations and some of the access points. On the left is how we started looking at intake and exhaust and integrating. Next slide, please. So a lot of different elements here. As opposed to the wall assembly, which we agreed to, and it was fairly quick, the balanced ventilation and heat recovery ventilators was a lot more work, a lot more sessions. The requirements of the 10-foot separation between the intake and the exhaust, and still the exhaust 3 feet from the window openings, really took a lot of time to integrate and fit within. SHA has some very standard unit plans, and we were able to slightly modify those to find homes for the ERV units. In some cases, we put them in closets. In other cases, we put them in the ceiling. It does take up space, and there's so many things affected here. The soffits affects the architecture. We did not want soffits everywhere. They had to be coordinated. You'll see that what we basically have is the ducts running up and down or north and south on the sheet are in the joist bay. They pop up and then back down. This was a long-term effort. I think it's interesting, maybe as we proceed in the future, we'll see that the unit design really changes to accommodate the specific unit. But I feel like we had another great teamwork effort on this. Next slide, please. Okay, so the integrated design for the photovoltaic array, thanks to this group, I'm working with Seattle City Light, there is an incentive for energy production. We started this early. We worked with A&R Solar through Ecotope. We came up with 3 basic systems. On the left is a ballasted system. In the middle is a bracketed system with supports that penetrate the roof, and same as option number 3. Next slide, please. So this was done fairly early, but what we were trying to calculate and determine is our payback. It was billed to us as a very high incentive. At one point, we thought to cover all of the roofs. But looking, and we had, the timing again is very important. It was fairly early. We had just decided on that layout. And some critical pieces here in the option 2 scenario, you see the payback period of about 8.6 years. Added structural cost. At the beginning, we really relied on the expertise of our team to try to identify that early. We created a range. We didn't get super deep, but that skill set really helped us. Next slide, please. So this really brings a lot home for me in integrated design. At the same time, we're working with site workshop, and we all know we have a green factor to work with. And the space on the ground is so valuable. We've got so much going on there, and we were simultaneously evaluating the cost of, can we put all of our green factor at grade? And it just didn't work for us. The owner and the team said, no, we have to get our green factor up on the roof, which ended up changing our solar array just to this west bar. Next slide, please. So in summary, the available roof area is critical for the PV, mechanical systems integration, the life cycle cost, but it's very interesting how everything relates, the impact on structural systems. So the gravity loads of the different systems, had we thrown more load onto that exterior wall, it could have threatened our 2x6 or 2x8 at 24-inch conversation. Fortunately, it did not, but it just goes to the point of beginning to get these systems up front. Ballasted versus tie-down support systems, the roof membrane and the penetrations are absolutely critical. No one does punching holes through the roof. However, we do have the skill set to do that properly. A lot of things to integrate. Next slide, please. Okay, so takeaways. A champion is incredibly important. The enrollment of the entire team, that this is what we are going to do. Measurable results from the beginning. I put in there the EUI of 20, and there's many different ways to get there, and we had other measurable, but that was the primary target. Team, team, team. I cannot emphasize enough how important that is. Working together and kind of choreographing a culture of, no, I can't just do this in my bubble. The questions, the emails, the communications really, really increase. And last but not least, use your Sharpie. What does this mean? Well, in kind of coordinating with Becky and Joseph on this, we were talking about, if there's anything to really impart upon the team, it's the early system identification, as well as the early identification of their system's compatibility. And our computer tools are incredibly powerful. But I was just kind of saying, there's times I wish we'd just get out our Sharpie, and with the skill sets and knowledge of MEP, and we can identify and what is a certain element about an MEP system that's going to trigger structural. And the ability to see that sooner than later is what the use your Sharpie is intended to land on. So with that, I will kick it back to Joseph. Thank you all.
Scott, thank you so much for giving us a a snapshot of an exemplary process that you went through to achieve exemplary results. One of the things that both Becky and Scott have talked about is what we call cost-efficient design, which is the elements of your building design before even thinking about exemplary measures, that your unit plan, your building layout, et cetera, all are optimizing the savings that you can then use to make your building a higher performing exemplary building. So an example that I think is good for us to share at some point in the guidelines is lean construction and target value design. This is a document that's been worked out over many years about how to arrive at really the best value for a construction project. It's what we would say that CEDC by Walsh Construction has been employing with projects in Portland and now in Seattle. And one example of that is what they did with RUNBERG Architecture Group and Lehigh for the Othello Apartments that is now in construction. And it's a project that was really on the rocks a couple of years ago because it had cost overruns. And so the team collectively, the owner, Lehigh, RUNBERG, and Walsh worked with all of the very specific team members that we've identified earlier, both structural engineer, contractors, equipment designers, and so on, to work out a $2 million reduction in cost. Even while other costs in construction have risen, they managed to get the overall project down $2 million, add some units to the project, and have a fundable project. So just to emphasize that the process they went through to revise the building design collectively was really successful. So with that, I'd like to invite questions and answers. And the first person I want to call on, if I could, is Lee Stanton, who's been a practical expert in this arena of construction management and project development over many, many years. And just ask if you might say a few words about your recent experiences in doing more early integrative design.
Thank you, Joe. Yeah, I'd be happy to. And can you hear me? I've been having trouble with my sound.
Yes, you're coming through loud and clear.
Oh, good. That's nice. I had to phone in, and luckily the sound kicked on halfway through. So you are way too kind with your comments. I just keep putting one foot in front of the other and try and learn from you guys about best practices. I think, let me share quickly sort of an arc that we went through with Walsh. We are now on that arc. We are now on our third project with Walsh. We started with the Liberty Bank building, where we learned early on about 2x8 construction, which was lovely. And then levered that into the station house experience, where we, which was really our first experience with early design integration, which allowed us to go through in pretty short order, figure out what the most bang for the buck we were going to be able to get in terms of particularly how we chased our C406 requirements, which for those of you who are practitioners out there understand how those all get juggled around. And we settled on 3 that have become almost standard at this point as our base. Which, to Becky's point, makes it a lot easier as we go forward on our next ones to say, okay, yeah, we know how these are going to perform. We're going to put our energies into refining those and to expanding those. And then the third in our trilogy is the Eldridge project, which is on the west side of Broadway between Pike and Pine. And there we are moving ahead of the 2018 code requirements for energy recovery. This will be, I think, our third project with energy recovery ventilators in it. Knowing that we are starting with our core C406 stuff, it's allowed us to put a lot of energy, which has been required in terms of trying to fit the ERVs into a building. It's a 6/2, type 3/type 1. We're up against our building height. So we're fighting floor to floor heights, which of course ERVs exacerbate, but we also are under the OH mandate to increase the number of units, which means we can't put our shafts vertically because that'll blow out our unit count. So the fact that we've got folks at the table early, we're meeting often. We have not yet submitted our building permit application, and we are still meeting every other week to work through the numerous coordination issues to get a building that is not UHI ready, but it's certainly a far sight more efficient than our usual building. We will be voluntarily also putting in a heat pump hot water system, so that's added to the fun and amusement of that particular project.
Well, thank you for sharing your thoughts there, Lee. I think it's going to be of great benefit to keep these experiences moving along and being shared with the larger community.
Absolutely. Thank you for letting me rattle on.
Sure. Questions and answers that might have come in on the chat or questions?
Yeah, Marty posed a question to me, which Grace very nicely helped answer, Grace Kim from Schemata. But, you know, Marty said if we have this issue of kind of starting over on a lot of projects. And so who should really, who should we say should step up maybe to own own a quality EID process so that it does get transferred from project to process or project to project. And if it's a shared responsibility, does it become less intense? And I thought, Grace, I enjoyed your response, which is saying, ideally, we're all stepping up as an industry. And so the focus is just there as a baseline, which I do think is actually happening with the code change and also the funding pressure on costs. So right now we are at this crossroad with the code changes are pushing performance, and then we still have the cost pressure. So it's happening. But where I've seen the most success is having at least an initial champion, someone who really says our initial goal on this project, and we don't know if it's feasible, but at least our initial goal and our first path is going to be a higher performing building than our existing portfolio. And for some organizations that they might not be able to define that. And in other cases, like SHA did, they said, hey, we know these programs and these incentives out here, and so we're going to actually set our target at 20 EUI. But then having the project architect and a project manager on the construction side also step up to that challenge and really work collaboratively. Once again, where we've just sort of seen the most success in really helping advance those projects through a very thoughtful process.
So Marty, would you like to bring us to a closing here? Do we want to try and do the Zoom poll?
I'm not sure we're able to get to the Zoom poll yet. We're struggling technologically, but I do want to just go ahead and pop your screen on, raise your hand or whatever, and let us know if you are more likely to engage in early integrative design, having heard from these folks today. It would be good to know. And I just popped something in the chat. I really want to express my appreciation again for all of you for being here. This is really, I think, the core element of all of what we're doing as we try to drive towards more exemplary buildings. And so It's always an honor to see all of you here and learn from you, and especially just want to thank you for taking the time. Again, be reminded, Lauren's got another one of these teed up for balanced ventilation and heat recovery. The recordings of these, as well as these PowerPoints and the charrette PowerPoints, are on the Exemplary Building website. And of course, the guidelines documents for all of these elements are deep into their formulation. So definitely want to keep hearing though from people. Let me not emphasize, I cannot emphasize this enough. When you have a promising practice, something that you think is valuable to your peers, we want to be in as much of an open source context as we can. Share liberally, let us know what's working, and let us know what you learned the hard way, because if any of us are honest in the building environment, we all learn by doing, right? And that's the most important thing we can share. So I'm going to jump to my next Zoom. I'm sure the rest of you are as well, but I see a little bit of sunshine poking up here in the south end of the county. So I hope you all get to enjoy that today. Thank you very much.
Thank you, Marty.
Thanks, Marty. Thanks, Joe. Thanks, Becky.
Good job, team.
Yes,
Thanks, Joe.
thank
Great
you
work.
so much.
Have a
Bye.
good one.